Good morning, class, and welcome to another lesson on electricity, where we make science fun. Today, we'll be looking at electrical conductivity of materials. In our previous classes, we looked at simple circuits and the components of a simple circuit. We will be taking the same concepts learned in those lessons and applying it in today's lesson. We'll be using our simple circuit, modifying it so that it can be used to test the electrical conductivity of a material. Now, before we begin today's lesson, we'll be having a fun game. Now, this game is called Mr. Froggy's Dilemma. So before we actually begin to do our experiment and fun stuff, I would like you to take a look at a short clip of Mr. Froggy and his dilemma. Good. So there you had it. Now, Mr. Froggy is in a dilemma. Now, we need to help Mr. Froggy to find suitable materials so that he can use to complete his circuit. Now, before we can do that, we need to clarify a few definitions. If you may.
Action.
Good. A conductor of electricity is a material that allows electricity to flow through it very easily. Whereas an insulator is a material that does not allow electricity to flow through it that easily. Right? By the end of today's lesson, you will be able to, one, modify the simple circuit so that it can be used to test the electrical conductivity of materials that are provided. Secondly, you will be able to name at least 2 conductors and 2 insulators of electricity. And finally, you will be able to group materials as conductors and insulators. Pause. On the worksheets that are provided, now I want you to make predictions by writing the letter I next to the material if you feel or think it is an insulator, and write the letter C next to the material on the predictions column if you think the material is a conductor of electricity. Good, right? Now that you have made your predictions, let us test those predictions to determine whether you're correct or incorrect. Good. Here we have a battery, we have our lamp or bulb, we have our alligator clips, and we have our materials here. So we'll begin by testing each of the material to determine whether it's a conductor or an insulator. The first material that we're going to test, it's a nail. Good. So here we go. Now there you go. The bulb is lighting. Now why is the bulb lighting? The bulb is lighting because the nail is providing a link between the gap so that electricity can flow in its path, which we discussed in our previous lesson, because we said electricity requires a complete circuit in order for it to flow. So we know that nail is a good conductor. Secondly, we're going to look at rubber. Here. Good. Now as you can see with rubber, our bulb is not lighting, which means that rubber is a very good insulator. Right? We're going to put this over here. Now let us try another material. Now we're going to try steel wool. And our bulb is lighting, which means that steel wool is a good conductor of electricity. Let's try now aluminum. I'm going to take our piece of aluminum there, put it in the gap there. There we go. It's lighting. So it means that aluminum completed our circuit. Therefore, it's a good conductor of electricity. Let's try now copper. I'm going to take our copper, put it in between there. Now there we go. It's lighting again, which means that copper also is a good conductor of electricity. Put it there. Let's try coin. $10 coin. Wow, it's lighting again. So that means coins are good conductors of electricity. Now let's try a piece of fabric. Take our fabric. Our bulb is not lighting, which means that fabric or cloth is a good insulator. So we're going to put it over here. Now we're going to take a toothpick. We're going to use our toothpick. Our bulb is not lighting, telling us that the toothpick is an insulator. We're going to use a piece of lead pencil, which is called graphite. Oh, now what happened there? Now graphite is not a metal, but it conducts electricity very well. So you can see this is our only non-metal that conducts electricity very good. So we're going to put it in the middle because it's not a metal and it's not. Now let's try a common toilet paper roll. Just paper. Our bulb is not lighting, so it simply means that it's a insulator. Now we're going to look at glass. This is a glass tube. The bulb is not lighting, which means again it's an insulator. Now we're going to try a wooden ruler. All right. And guess what? It's an insulator. Good. So now let's test your prediction against the actual results that we found. So we found that nail is a good conductor. We found that rubber is an insulator. We found that glass is an insulator. Coin is a good conductor. Pencil lead, a non-metal, we found that it is a conductor. Aluminum found to be a conductor. Fabric is an insulator. Wood, an insulator. Steel wood, a conductor. Paper, an insulator. Toothpick, an insulator. Good. So now from the video that I showed you, what are some materials that you think we can use to complete Mr. Froggy's circuit? John, can you tell me? Correct. Steel wool, Alessa? Correct. We can use aluminum. There you go. So we can use most of the metals to complete Mr. Froggy's circuit. What about the pencil lead? Marissa? That's correct. It's a non-metal, however, it conducts electricity very well. So from our activity, you can see that we can form a few conclusions. One is that Most metals are good conductors of electricity because they allow the flow of electrons freely. Whereas most nonmetals, except graphite, allowed electricity to pass. However, most nonmetals did not. For example, plastic and wood and paper. Alright? Now, additionally, the properties of metals and nonmetals determine their use in electrical circuits. For example, we use insulators for things like switches because we don't want to come into contact with the exposed wires. Whereas copper and aluminum are used to make things like wires because they are good conductors of electricity. Moreover, you would be having a nice little homework. Your homework would be, you will be drawing a simple circuit diagram that can be used to test liquid substances for their electrical conductivity. Thank you.